Thanks everyone on coming on Saturday morning. It is raining. Okay. I don't want to be so loud. Okay. Suddenly the technical topic comes. Okay. The voice go up. Okay. That's fine. So before going to the topic, before introducing myself, I want to know the audience. Okay. I think we have around 15 participants on online and we have around 30 plus people on the here. Okay. How many people are working? How many people are from? How many are students here? Okay, great. Okay, so how many are working professional? Software engineers, data engineers. Okay, machine learning engineers. Oh, great. Okay, good. We have a participant wider mobile developers. Sometimes I forget, always forget. Okay, good. They will feel offended. Okay, guys. Okay, I'm coming here. Okay, you will not even calling out. Okay. Good. So I want to introduce myself. I'm Ayyanar Jeyakrishnan. I have around 17 years of experience in IT, and I actively participate in the community activity and sharing my experience, knowledge on multiple topics. And I'm more passionate about machine learning operations. I have a good experience on the data platform engineer, DevOps, and multiple technologies. While you work on Azure and other clouds, okay. And this is a community I'm so active at. And thanks for ACAM to give me opportunity to speak in this session. So I'll talk about this community a little bit. Okay. So this is a Cloud and Love Tech community. Anybody who is students, okay, who want to learn about the technology like Python, Terraform, DevOps, Cloud, Linux, you can actively follow that. It's all free. The session will be conducted by the industry veterans, mostly people who have at least 15 years of experience, have a good knowledge about, and have a training hours of 100+ training hours. They will be giving a session. And all the sessions are free, and you can actively check in the LinkedIn. You can actively participate in the LinkedIn, or you can WhatsApp this number. We have around, I say, 70+ WhatsApp group because it's keep growing. So because of the WhatsApp limit, we keep growing that. Anybody interested, please join. Okay. And who want to contribute also as a session or topics. And we have a frequent session, how to prepare yourself as a speaker. Okay. How you can come out to the stage and make you as a speaker. Okay. We have a separate session where we mentor you to come to that particular stage. Okay. That's all. Now come to the session. This is a little bit intermediate. Okay. We have some MLOps basic session 2 months back in Microsoft Office. This is a little bit intermediate, but don't worry. How many are ML experts here? So people are great. Okay. So good to have 1 or 2 people are experts. So, but at the same time, I want to cover the basis. If I don't want to go to the code where people will feel sleepy even though lights are on. Okay. I'll go a little bit on the topics at the high level. So you'll have an understanding. And when you get a chance to work in a real time, you can correlate about this session. Okay. So we will touch upon few top technology stack in Azure machine learning service, of course, definitely. And there are few services or the few features announced in the last Ignite, Microsoft Ignite, the Azure registry and responsible AI and fairness. And of course, we are going to touch upon Azure DevOps for building and deploying it. And Kubernetes, I'll find a time, if possible, I'll touch upon how it will work. And definitely a little bit on the MLFlow. And I'll have a few checkpoints within every 20 minutes, I'll have a few checkpoints where I'll take up your questions, okay? Because I want this to be interactive and at the end of the session, you need to have some takeaway, okay? Whoever the student, you need to have some takeaway of what is this session, how you're going to be using this in your future, and who are working in industry, how you can really apply this to your session. And you have a code given at the session where you can go, people who are really working in a real time, take this code and test it. Students, welcome, please go use this code, read. It's not so hi-fi, it's all available, so you can check it. And before coming to this machine learning operation, okay, I work with a data scientist who are all PhD holders. and they have very good experience. They're fantastic in building machine learning models. They get the data and then they build a model and it worked perfectly in their laptop. How many people did this before? Even students, you would have tried some machine learning model. How many people did before? Oh, fantastic. Okay. So that model worked well in your laptop. Okay. The moment you go to the production, you have a different level of challenges. Okay. So in your laptop, you will give few data and it will work well. The production, the moment it go to the production, a lot of people consume. Imagine you build a model for the speech recognition. In your laptop, it works fantastic. Okay. Think about it goes to the live as a model, like how many people are consuming across the world, like Alexa or Cortana, how many people are using it, how it work at that scale, because that's where the MLOps come into the picture. Because here we need a lot of collaboration. To have a UI, you need to have a full stack administrator, and to have build a software which integrated that machine learning, we need a software engineer. To deploy this to the production, we need a DevOps engineer. And to build the machine learning model, we have a data scientist. So think about how many personas involved here. And that's where the big challenges comes, okay? When multiple people work and they don't find the cohesiveness to build as a product, okay? This MLOps help all the people work at their zone and deliver the product, okay? So that's a main objective, okay? All the enterprises are facing these challenges, and Microsoft come with a few of the technology and a few of the, I say, accelerator, which helps you to go to the production or go live and set the landing zone or the platform to kickstart your machine learning operation. Okay, I very much worried about putting this slide, but because it's go too basic, but at the same time, I was expecting some students maybe join. That's why this one. So this is a classic MLOps life cycle. Okay, so anybody know where this will start? It's in a circle. Data. Okay, that's fantastic. So it starts with the data. So you need to have better understanding of what data you're working with. Okay, as a software engineer who build the full stack, do you need to know the data? Okay, as a DevOps engineer who protection the model, do you think they also need to know the data? Yes, the answer is yes. You need to know what is data. You don't need to go and touch the data. You need to know, okay, what data they are working on. And definitely after the data, where this will go, model or direct the next cycle. So it will go in a round and round. So they first need to explore the data. Okay, imagine you have a data of a taxi prediction or fare prediction. Say Ola or Uber is coming up with a predicting the taxi before you are like, it may cost this much money. So they're coming with the prediction. Okay, so how the prediction is happening, you need to, and before that, they have collected a lot of data and the peak time, everything they collected, and then they come up with the model. Okay, so before and to build that model, they want to first explore the data. Where is the starting point and what is the end point? What is the hours and how many people are driving? It's a share or it's going to be individual. Okay, so that is what the explorator, they will understand the data, then they will build a model, then they package it, and then they go for this release cycle. So here you see the machine learning engineer work in that particular zone of read the data, explore the data, building a model. And the development team or the DevOps team will help them on package that model and put to the production. And definitely once go to the model, and they need to have a good monitoring system, whether your API is working fine or not, whether the accuracy is good or not. So if I'm deployed some model, and if it is predicting from say Manyata to here, it is just ₹2. That means the model is not working fine. So they need to constantly monitor the model, whether it is good or not. Okay, so I'm going to pick 4 topics, 4 important things. I'm not going to cover full life cycle. I'm going to talk about the 4 important things which you think, if you are working in a machine learning, or even as a student, if you are working in a machine learning, you need to bring this concept in your at the very early stage. Once you go to the professional, it will be helpful. And people who are in professional, I think you may be already practicing this for another iteration. Version it. Okay. who have all the code in your laptop not have in source control? And how many times you forget to push the code to the source control? And anybody faced an impact that it worked fine in my laptop, I forgot to push the code, somebody did the code commit, or somebody committed the code, it broken all the stuff I did? Anybody have experience? Even college students, you may be using a GitHub or version control. So that is very important. When come to the MLOps, not only code involved, you have start with the data. Whatever the data you're presenting to the model, it has a certain schema. As I said, very simple example, what is the starting time, what is the end time, and from to destination, this is a schema. I cannot suddenly put one more column and say predict properly. The machine learning, the model cannot predict. Okay, so this schema need to be there, and some model like a time series data need to have a certain window. Okay, if I'm seriously giving a 2 hours of or 5 hours of window, the model will predict properly. The moment I give every 5 minutes the particular data, it will not predict. So sampling over the time, and the volume of the data also matters. The moment the data is coming fast as a real-time stream, some of the model will not predict. So while you are building your data, you need to have a version. Okay, this is my schema, this is the frequency my data will go, and this is what the sample data or sampling over the time the data will have. So while you are building your enterprise scale machine learning MLOps platform, the first rule is make sure your data is versioned. It can be a simple CSV file which you want to use for your prediction, but the moment new data comes, that need to be versioned, because when you introduce a new data, there is a high probability the model accuracy will go down. Okay, so the data versioning is foremost and important. And then model. So you build your model, okay, and it worked perfectly. And the new engineer came and he found I can do better, okay. And he deployed a model. And suddenly what happened? It worked perfectly for the first 2 days. Then it started coming down, accuracy going down. It is coming below than what you are expecting. Then you want to roll back to the previous model. So the model versioning is for most important. And same thing, if you are building a data pipeline, the versioning of the pipeline also important. We will go through all those things. Then you need to have business code. So not all the while come to the machine learning operation or the machine learning model, not always the algorithm and model counts. There are a lot of custom logic will be built as part of the application. That's why the developers we were seeing in the cycle. So that also makes sure they are building a code and they are versioning it. So the takeout from this slide is make sure you version the data, you version the model, and you version your software. Okay. I'll have a quick checkpoint. Everybody agree on this? Okay. Good. Thank you.
Is there any tool available, say for example, different versions of data and then have different versions of source code? And I need to keep track of which version of code is working for which version of data, right? So is there any utility of the tool available so that I know upfront?
Yeah, today we are going to see. Okay, there are a few tools. I just don't want to break the surprise. It's valid question. Definitely, let us. Okay, so MLFlow and open source integration. How many people can claim that I'm not using any open source in my project? Not even I'm taking code from the GitHub. Okay, so we will make it, most of the enterprise product we build, we always have some requirement to integrate with MLOps. Azure predominantly use MLFlow on their machine learning workspace for various reasons, particularly MLFlow tracking. I'll start. There are 4 important things in the MLFlow. I'll start with the first one, MLFlow tracking. So whenever you build a model or run your data pipeline is nothing but take a source data, do some crunching, and store the final data. Okay. So I'm just keeping it simple. So in this pipeline, we want to track what is the source data and when it came and what kind of crunching I did it and where it's stored. So it's a tracking. Okay. And the model, we have a machine learning model. Okay, so which data I use for building the model and where am I storing it? So those information, again, it will be tracked by the MLFlow. We will see all those things. And we need to build a share. Once the model is built, we want to store it in some as an artifact that the other team can consume. Okay, imagine you build a wonderful model, okay, and there is a new team want to consume. You don't want them to go to all the same life cycle again. So they want to use your model and whatever you experience, where you need to store as a registry, which will be used by them just to consuming it as a API. An MLFlow project and all the format. Okay, you have the MLFlow has a standard format where your model will go under this particular directory and your data will go under this particular directory, your artifact go to this particular directory. This will give us standardization, which will be used for deploying or move the code from the different layer. Okay, we will definitely go through this one. Okay, anybody worked on MLFlow here? Okay, no problem. I'll just give you a high level overview and bring the code. And very important thing, I think people who are going to develop a machine learning model in future at the enterprise scale, this is very, very important. And fairness. What is fairness?
Not be biased.
What is should not be biased? Any example?
Mostly kind of reflects and say gender. It's more common to
Case, you just imagine as a column. Here it is saying white and non-white. There is a bias. Okay. And there is a one more attribute, the gender. Okay. Unprivileged group. This is a privileged group in the sense it is biased towards it. Okay. It's just giving a salary prediction. Okay. Adult census income. Okay. And you can see there is a way to mitigate the biases. The tool is already available. You don't need to build from the scratch. The already multiple algorithm was built and Azure already have something called responsible AI. We will go through this demo and where you can mitigate this algorithm. After mitigating the algorithm, you see there is a accuracy after mitigation changed from 83 to 82, but it is mitigated. Okay. So like the data which we give an input should not have any biases. It need to be fair. Okay. So each data will have a different level of understanding. You need to be, that's why the data exploratory is more important, and make sure that you have a better fairness. Okay. Then comes reliability and safety. Any example? But everybody know this example.
personally.
Yes, but the machine learning model we build need to have a reliable and safety. Example, I build a model which which will deploy to my self-driving car, and it just completely ignore if I'm walking with a dog. No, I'm still a pet lover. Okay, then so that is what the reliable. Okay, your model need to make sure it's reliable. And one more thing is privacy and security. Whatever the data which is build or model is predicting, it should not take the data. The model need to come to your place. Let's say if your mobile is predicting something, it doesn't, the data should not transfer to somewhere. And every government has a different law, so it need to adhere to the law. And one more thing is inclusiveness. Okay, what is inclusiveness? Any idea? So it's not forget about the machine learning, all those things. It just is more general topic. Any model you are build, it's a general knowledge. Okay, so inclusiveness. Don't intentionally leave out anybody. Okay, you need this. The fairness is to make sure it is not biased, but inclusiveness is don't intentionally leave anybody. Okay, let's say I'm coming from a different place. Don't ignore it. Okay, so then transparency. Sure, whatever the model you are building, it need to be explained. So imagine I built a model. Okay, my C team is coming. Very good. Your model is giving a good accuracy. Can you explain it? Okay. How can you explain? You cannot, you don't need to explain them. I built it a Python code and deployed in a model. No, they're not interested in it. They understand what is the business context. Okay. This is the data and I applied this algorithm. It is giving a predictability. And this is my fairness. This is my inclusiveness. So the model need to be explainable. Okay, it need to be transparent. Okay, so that is what transparent. And the third one, the next one is accountability. Whatever the model you are building, you need to be accountable for it. Okay, let's say if the model I build, if it is predicting wrong, I'm accountable. Okay, so that gives accountability on me to make sure I'm covering all the bases, make sure my model is fair enough, reliable, security, and inclusive, as well as explainable. Okay, so there is a service called Responsible AI as part of the Azure ML stack, which will cover all those things. We will see the demo.
So what about scalability of a model?
Yeah, I'm coming next.
A question on fairness.
Yeah, please.
So fairness would be delivery. Let's say you're trying to predict income, right? From, let's say, people passing out from premier colleges, not good. There's an inherent bias that people passing out of college. But that is what the data structure is. That is what is the concept or conceptual data that the model holds, right? So when you try to, let's say, balance it off to a certain extent, like in this, okay, it was okay that you had lost maybe 1% of predictability,
Accuracy, yes.
accuracy. This can accept to the extent. But then if there is a very strong correlation between two variables, which is income versus institute that they pass on, the rating that they pass on. It might skew the model to a large extent.
Makes
So,
sense.
yeah, so when you do that, for example, balancing act, reweightage is one very good way of doing it. Any other methods in which you do?
There are multiple algorithms, okay, which give a weightage to your data, and based on that, it will predict. Okay, so I'm not going deep into that. Okay, but there are multiple algorithms. It will take into the context. Okay, imagine there is an institute which average their salary is 30% plus. They will take into the consideration. Okay, this parameter give a value of 30%. It is a common across all the data sets. Okay, then it will take a prediction. Okay, so it will not bias. Yeah, you are right that data will be skewed, but that's the nature of the data, and that the data is valid. Okay, and this is just it will not go and affect the model unless you change the data. It will give you the view. Okay, this is what the data. This is a responsibility. We are thinking this is fair, and it is biased or it is not fair enough. But it is our responsibility to go and change the data. Okay, it just give you the tool to explain the model. This is the way we are predicting. Because previously everything is black box. Okay, before say 4 years back, there's I'm okay. I cannot call myself it's a 4 years back. Before that, there is no something called explain model. The model will work, and everybody, not at the research side, everybody don't know how the model is working. How you come to this prediction, nobody knows. Now you can go to the data by data, column by column, attribute by attribute to identify why this is predicted. Okay.
Just to add one more thing, if you do something called shapely values of line.
Yes, yes.
The libraries available in Python, which will give a visual representation of explaining it.
And Microsoft is using it, SAP. SAP. SHAP.
Yes, it's based on shapely values.
Okay. So what I say, I can give you a platform which a single click install, give you a framework. Right from commit the code, develop the model, build the model, deploy the model, and the model will have all the responses, all this what we discussed, responsible AI, and registered the model. What if I say there is a framework available? How many people like to adapt that? Okay, fantastic. So this is not what I invented. Okay, this is already there. There's a GitHub link I have given below. That is developed by the Microsoft. This is Microsoft Accelerator. So you can go to this GitHub. You can use it. There are a lot of commits happening. People who are really working in the real time, you feel that you can add more, please add. Okay. I came across this 5 months back, and it's really interesting. I have a few more ideas of contributing also. Feel free to contribute. This is a framework developed by the Azure. Okay, it will be a little bit small, but I cannot zoom this one more, okay, to fit into the slide, okay. So everything starts with the data. Since Azure have multiple data sources, you can be a data lake, which is nothing but everybody have a little bit idea about Azure, right? Okay, that's fantastic. So it can be a storage like Azure Data Lake. It's nothing but a blob, and the data can be either SQL, which is a data structured data, structured transaction data, and it can be a Cosmos DB, or it can be real-time events like IoT. Okay, then they sorry, they can the second and third step. This is where we need to understand how we can work in a cohesive manner. Okay, the administration setup to set up the workspace for the engineer, the machine learning engineer to work. They need a repository. They need a compute to run their models. Sorry, the administration, they need to make sure that the data is available, and they have a repository set up for the machine learning engineer to work up, and they need to have a security enable everything. The third layer is where the machine learning engineers will work. They read the data, explore the data, and they do the feature engineering. Feature engineering is nothing but understanding your data, make sure the data is whatever the data needed for your model, or if the existing data, you can transform into the additional attribute for your model prediction, and build a model and train it again and again, make sure until you get a prediction. And also you build a responsible AI and everything as part of your model stack. So the fourth one is a continuous integration. Now the model is ready, now the DevOps engineer come into the picture, where they will take the model, deploy into their stack. But definitely they will not directly go to the production. They deploy to the development environment, and then they validate. And whatever we're deploying in a development environment, that seamlessly need to go to the production environment. And then we need to have a monitoring setup, make sure your model accuracy is good and throughput is good. It doesn't mean that you invoke something and you need to wait to have a whole sip of whole coffee before the prediction comes. No, that's not how the real-time inference work. Whether the model is going to be batch or a real-time, that need to be deployed, and that need to be monitored, and the accuracy level also to be monitored. And there is a concept called model drift and data drift. I'm not going to touch upon, but we can talk after if the time permits, we can talk about it. This is a framework developed by them where you can quickly provision this. Okay, this setup you can quickly provision. Anybody interested, you can take this code after today, just sit for 1 hour, you can set up this one. Okay, so before I'm going to the demo, I want to take your opinion. Okay, who is working at the machine learning engineer? Okay, so do you think this will be really helpful for you guys and addressing your current challenges? Okay, yeah, definitely. So this is what the GitHub link, Azure MLOps v2, and here you have all the documentation. Okay, you can take a photo if you want. Otherwise, I think Acamp will share this one, and the lab demo. So I just forked the repository and made some changes and created the custom code and built it. Okay. So you can clone there, or you can refer this, how I pass this code. So high level steps. Okay. You need to first go check out this MLOps v2. And after that, you need to make a changes in this particular file. I'll show this file. Can we go parallelly or demo? Who like to see in visual more than seeing? Okay, good. Let's go to the demo. So I'm going to switch few screens. Okay, where is my GitHub? So Bangalore reactor. So I'll follow the steps I have given so that you will be able to do on your own. Okay. So first we need to check out the MLOps v2. Okay, great. I need to go to the particular repository. MLOps V2. Anytime you do the Google, it will be first one. It will come into the picture. Okay, and this is not a real code. This is kind of a cookie cutter or say boiler template where using this code, it will build your real code needed. Okay. Here, you don't need to worry much. This is the place you need to use infrastructure. Okay, how many are DevOps? Here, okay, so it helps. And how many people you are working in Terraform? Bicep? Okay, Ansible. Okay, so how are we going to provision this infrastructure? Okay, just run this shell script which provision all the infrastructure. Okay, so all the code which is needed to build the infrastructure. So infrastructure, how are we going to provision? There's a Bicep, which is automation tool by the Azure, and also use a Terraform, which is a cloud agnostics tool, which you can provision the infrastructure. You have an option whether to select the Terraform or not. And this template will be whatever the slide I have shown, they will little bit vary between the framework, between your framework to framework. Let's say if you are using a classical machine learning, like a logistic regression, linear regression, this framework will work well. And if you have a computer vision or NLP, little bit changes will be there. So you have to select here whether the classical or a CV, because based on that, the YAML file and the required code will be created. And MLOps version, previously we were, whether you people are who love to have it in a Python SDK, you can use a Python SDK. If you are is CLI, I'm a CLI person, I'm just going with the CLI. And Git folder, this is where very important. You need to create your repo, empty repo, and give you a repo path where this code will automatically push it based on your option you selected. It will be created and given project name and organization name, nothing but in a GitHub, if you're creating a separate organization, it's nothing but a placeholder. It will separate placeholder for a new repository. It will be stored there. Yes. And this is a normal MLOps template. You can fork into your organization so that if you want to do some custom changes, you can fork into your repository and give your information. And whether this code is going to be in a GitHub action or Azure DevOps, based on your selection, the code will be stored into the repository. I'm going to select a GitHub action. So it's selected a GitHub option. Based on this input, it created a code. This is what I given, and it created a code. You see this one. It created this code. So now I give a high level understanding of this one. The data science team, they can come here and they can come define the libraries they needed here. What are the libraries they needed for building the model? They can come define here and they can keep their code here. Source, train the model and evaluate the model. Any custom scripts they need to keep. They can use the same code commit. We are talking about the versioning, right? They can use the same code commit for this. And the data, currently it is a flat data. I'm keeping as a small CSV file. First thing we need to understand what data we are going to predict. We are going to same thing, the taxi prediction. Source to destination, we have two vendors and make sure this is predicting which vendor is giving a better price. Okay. And also the responsibility will tell on what basis I selected this vendor, not the other vendor. What is the fairness and what is the biases applied there. And infrastructure, this is very important. We are talking about the second one to set in the presentation. Where's the presentation? Okay. We need this whole infrastructure, correct? We need this infrastructure for the machine learning workspace, and we need to set up the repository, and we need to create a deployment infrastructure for staging, production infrastructure. Okay, everything will be done. The boiler code template. Okay, it give a basic infrastructure. You read, understand, you can evolve from there. Okay, it will be done by this particular folder. So now, did we cover the most of the bases? Data versioned. And the data, definitely you can keep it in Azure Data Lake and version it, and the data will be versioned. Okay. And how model, I will explain that model. Okay. And MLOps is where we will plug both the development, the model and the end to end, how the deployment is done. So this is highly structured. This is how it is structured. So now you can use a single version control to version your data model as well as infrastructure. Here comes the second step I need to do. High level step. I'll go back again, the high level step. I verified I run the sparse checkout. Once I committed the sparse checkout based on my requirement, I run the script. It automatically pushed to the repository. Then we have a repository changes. We have two files, config files, to tell how our infrastructure is, which region we want to deploy. So I can say this need to be a version Europe, or it need to be what is the namespace I want to prefix, and what is the suffix need to be done so that it can be unique. ML workspace is, I say, it gives you the end-to-end building a model, training a model, and deploying the model provided by the Azure. We will go to the demo. So I'm going through the script, okay? And there is a service connection need to be established. Service connection is nothing but Azure DevOps. We use it for deploying the services, like provision your infrastructure, provision your model. We will use the Azure DevOps. From the Azure DevOps, we are authorizing to the giving the provision to the Azure DevOps to go and deploy it on the Azure ML workspace. While we are going to the demo, you will come to know all those things. And I will show you that Azure DevOps connections also. This is my Azure DevOps. And from here, I created a service connection. Where is my service connection? Here, I have created a service connection. Service connection, yeah, here it is. I given the credential sorry, to deploy it on the target environment, that nothing but a workspace. It will ask for the credential. I given the credential and give it, okay. You can follow the, that's a quick start, which will give you everything. I also given the connection to the GitHub because my code is on the GitHub. You need to take from the GitHub. The Azure DevOps need to have a connection to the GitHubs to read my code and deploy the stack. Deploy the Azure ML workspace using Azure DevOps. Yes. Now let's go to the real demo. So first thing I did is I want to set up the infrastructure pipeline. This is already deployed. I want to make sure that my demo is working properly so that I can just here. This is the first pipeline. What does it do is it is using the config.yaml file and deploying the stack. What does it deploy? It created the, you can see the steps. It installed the Terraform because I used Terraform as my infrastructure as a code. It install, it init the Terraform, and it apply the Terraform. And what does it do is, I need to move this one. This is a apply. It created the Azure machine learning workspace. Okay, so you can see it created Azure machine learning workspace. Okay, so I no need to go and provision it manually. I just need to update this and it automatically provision the infrastructure. And then I come to my portal, Azure portal. Okay, quit. This is a workspace it's created. Both the development and production it updated. I used both develop infrastructure.yaml file as well as I use the production.yaml file, which I have given a different entry. It given a workspace. And workspace comes with the studio URL. Okay. Any freshers who are not done this one before, please go try explore Azure ML workspace. It's really fantastic. They have a lot of samples where you can just play around. Whenever you have time, 1 or 2 hours, you can play around. Okay, in this workspace, it has all the information. It have a notebooks. Notebooks is nothing but it's IDE to create your, explore your data, connect to the data, and build your models. And here, the code which we have the pipeline created this workspace. Okay, I'm not done anything created manually. I just ran this past checkout. We checked out the code, And using that output, I provision the whole infrastructure, ML workspace. And if you want multiple one, you can go update that particular script, development, staging, production. Currently, I'm only focusing on dev and production. I just need to, you need to just copy and change the variables, and it automatically provision the infrastructure. This is the first step. Any questions? I am going to switch over the code and pipeline. Any questions on this? People who are attending online, you can also ask, or you can chat and watch out the chat if you want. Anybody completely lost? It's okay. Nothing wrong. Okay. So now you need to deploy the Azure ML workspace using Azure DevOps. We have done it. Next, review the data set, infra details, pipeline details. We have checked. Now I come to the MLFlow, important part which you asked, right? Okay, I'm just going through them. So first question you asked is, how am I going to version my data? The data, the simple way I can explain is, if it is a CSV data, keep it in a data lake, Azure data lake, and it's version enabled. The moment the data is changed, you always keep some standard naming convention. So the moment data change, it will be version. If you can always go and roll back. And come to the model part. Go to the train. Let's say I'm training the model. Okay, this is a train.py. I can use this one. Control F, MLFlow. So MLFlow, we were telling the MLFlow to just parameterizing what model am I using, what model I'm using, and what is my estimator, and what are the hyperparameter we are using. So all the input we are. Any problem? No.
Can you all see now?
Yeah.
So you are asking how we version the model, right? The model will come with the variables of what data I used and what hyperparameter I used to train the model, and all those information you can parameterize in the MLFlow. It's all declarative. If I'm not declaring, of course, it will not come. And then what metrics? So each type of algorithm use have a different metrics, whether it can be RMC or it can be a R2 based on the metrics, what metrics you want to monitor, you want to mention, and where is your artifact, how you are going to store the artifact. All the information you will be storing into the MLFlow. In the training stage, of course, you will do the same thing in a deploy stage, but this is a training stage which will you version your model parameters. And definitely the register PI is important, where you will register your model. Okay, MLFlow, here it is. See, I'm registering my model. That means whenever we are running the model, it will register all the information. Okay, if I deploy the model second time, if I change it some hyperparameter and do the deployment, it version as a separate. This is a new run, and this model, it has this particular version. We will go through this. We will see this from the demo. So high level, I want to check out. So deploy the ML pipeline. Okay. So ML pipeline, it can be done from the GitHub. So you have, anybody worked on a GitHub action? So what does it do is it will deploy that model. Sorry, it will train the model. It will read the data, apply the model, and create the whole stack. People who are not done this one before, I will show it in a visual. What does it do? Come here. Once you run the pipeline from the GitHub, these are all files. Okay, you just need to map the YAML file and it'll run. So you can fantastically see this one. Okay. So it's a concept. People who not done a machine learning, if you want to know the high level concept, it will do whatever we were showing in the screen before. Okay. So it read the data, prepare the data. Oh, wait, I don't want this. I can show it this one in a much better manner. Okay. So I trained the model and it evaluated the model and it registered the model and it created the responsible AA. It created all the responsible AA stack like a error analysis and counterfact, explainability, everything it deployed. Okay. It's not funny. So the first step I did is created the infrastructure. The second setup I did is, okay, this is what it is. Okay, go. Yeah, that's all the whole pipeline. Okay. It will come to the train data, validate the data, test the data, train the model, evaluation model. Everything the responsibility is connected to what data I use for training, what data I use for evaluating, how I test the data, everything will be evaluated by the responsibility. Now I go to this particular, yeah, it is done by SDK. I not done it. I'll show you the pipeline, how it was done, okay? And I'll quickly go to this particular, okay. Sorry, I need to go back. Here we did, first we set up this one, correct? They set up the infrastructure, ML workspace, everything, which workspace we set it, we given a data set, okay? Now, the machine learning engineer, the same repo, whatever the code we have in the repo, the same repo we were used for build the model, train the model and evaluated the model and created a responsible AI. So the third step is also done. We have a different pipeline. First one I told infra-dev.pipeline, and this one will use a different file. I'll show you that particular file. That is my GitHub. Okay, here it is. So here, infrastructure, pipelines. Oh, sorry. Okay. This is a pipeline which have all the information, responsible AI, everything. Okay, it will go to the template and take it 1 minute. Updated pipeline.yaml. Okay, train, yes. Train pipeline.yaml. We train the data, test the data, evaluate the data, train the model, evaluate the model, register the model, and then create the responsible AI and explain AI and cache file analysis. It's a counterfactual analysis, nothing but it mitigated, right? So it did everything and did some error analysis and gather everything and shown as a dashboard. So what I did is I just went to the GitHub action, pointed this file, and since the code, everything is in the same repo, we taken the Python file, train file, and deployed to the stack. So the second step we completed, okay. So this is the second done, third done. Now we want to deploy the model. Okay. Deploy the train model as a batch endpoint or the real endpoint for the outer loop. Same thing. I come to the Azure DevOps because I want to show some example on GitHub action also. I want to show some example on Azure DevOps also. That's why I'm switching between both the stack. You can do both the things on the same place. So go to the MLOps reactor and you go to the pipeline and come to the pipeline. You have something called batch endpoint. Yes. Batch endpoint pipeline. it created the batch endpoint. Don't think like I'm only 2 times failed. I failed 67 times. It deleted it so that I look better. Okay. So it created a endpoint. Endpoint is nothing but I want to show the real-time inference. So it create a compute, it deploy your model. Okay, this is the endpoint file. Okay, that you can have it in the repo itself. So info DevOps pipeline, you can online endpoint. So you can see it provisioned the image and it created the template. It all in the cookie cutter. It's in a template. Okay, don't think I did it. It's all done by the accelerator team. Okay, I'm just doing the demo here. But there are a few things I find interesting on modification. I made a modification and doing it. So I deploy the endpoint. Endpoint, I'll show you from the console. There it is. Go to the endpoint and a real-time endpoint. Where am I? Okay. Before doing the endpoint, I want to touch upon a few things. You are asking about model, MLFlow. Sure, every time I train the model, I'm not changing any data. I just keep running it again and again because it's failing at multiple stages. So here, the taxi model I built, you see this artifact, right? What is the experiment run and what date it is ran, created on this, created by whom, and this is what the MLFlow is using, and where this asset location is stored. And here you can see what is the hyperparameter I used, what is a file it is, all this information here. Okay. Pickle file, what environment I am using. Okay. What version of this SK version. Let's say if I'm using a different package version, sklearn, scikit-learn version, that also will be audited. Okay. Because the new package will have a different feature, which may impact our model. So all those information, this is completely tracked by the MLFlow. So your model also version, your environment, the package you use, everything will be versioned. Okay. So that's the advantage of MLFlow. Now, how many people, let me come to this topic. I want to show the deployment model.
It's not at one place. Data is, the information is scattered. So the way I want it is I'm actually working on a model and I've done many, trained it. Now I have a lot of artifacts. And so at the end of the day, I have, say, for example, 10 models, M1, M2, M3, till M10. And then I have different versions of data, V1, V2, 10. And I have different accuracies for these models on the different data. There could be combinations also, like model 1 worked on version 1 and version 2, and it's giving this accuracy. So what I really want is, this could be a stupid question, but what I really want is there a place where these models are keep generating itself, and then it's selecting the data, and obviously I'll have to change the data for me to get the better result, or for me to get the better accuracy. Right? So at the end of the day, I just want a dashboard where which model has worked based on what data and which has given me the best accuracy.
I think you can do from here itself. Okay. For your question, I can answer in a two manner. Okay. So this is a version and you can compare the versions. Okay. You can compare the version also. Okay. Compare.
There's a
Comparison. Okay. So you can compare the model and what is the, you need to run as a compute. Okay. You need a compute to do the comparison. And the second thing is very important challenges people do is he's an excellent data scientist. He built everything. I'm a lazy goer. Okay. I say, this guy did everything. Why don't you share? Okay. He said, come to my workspace. That guy said, no, I'm a different team. I cannot use your model coming to your workspace. So then at least share it. Okay. Previously, we don't have the sharing. Okay. So he need to do all the setup, everything and build, train and come to the model. Okay. So Azure announced something called Azure Registry, where you can train your model and your model is perfect and you can share this model to the different workspace. Okay. That is what I'm going to talk about in another few things here. So the data scientists explore the data and created their wonderful model. I'm giving only model as an example. You can share multiple things. Example, environment. Environment is nothing but the conda.yaml file or whatever the packages you are using, which work perfectly. I don't want them to go and use a new version. Come on, it's working in your laptop, in your workspace. It's not working in my workspace. So you're sharing the environment also to the different people. And there's a component in your pipeline. There's a certain component which you write a beautiful code, which data crunching. I don't want to do it again. You go share this particular component to the different workspace. They can use that workspace and do it. So they announce a registry and where you can share this from one workspace to another workspace. Okay, same thing. You got the concept on this workspace, right? I'm coming to the demo. So I created the model. I deployed the model here, but sorry, I created the model here. But what am I going to do? I'm going to deploy the model in a different place. So how I can go? Here's something called registry. I created a registry. MLOps, this is the registry I did it. The registry can span across multiple regions also, because sometimes you build a model and different people want to use that particular model. So they want to use it. So this registry, I created this registry. And if I come to the model, this is a model which I deployed it into this particular registry, but I will show where is the lineage of this model. So this is created by this model. We build it on different workspace, and the MLFlow given this particular artifact, all this information, what we are sharing here. Okay, but I'm going to deploy this model on a different workspace, completely different workspace. So I have a development environment. I should have done this on a development and moved to the production, but I just tried it. Endpoints. So this is an endpoint. Okay, I created and I deployed this model. Okay, and you see this registry, the model ID. The model ID is coming from registry, MLOps, ML registry, and model taxi version. But this model is coming from the different workspace. I registered that particular model to the registry, and I said, share it to the different workspace. So you can, if you have multiple workspace, you can share with multiple workspace. If you want to restrict it to certain workspace, you can restrict it to a certain workspace. I shared the model. I deployed the model here. So I built a model in one workspace. I deployed in a different one. I'm going to consume it. Consuming is nothing, but this is how your application, the full stack developer, if they build a model, machine learning engineer, they just give an API where you can integrate the API into your full stack, and they will give a user input and it will predict. So come to the test.
So if my model has some keyword secrets and all, then how it will work?
Everything you can keep it in a Azure Key Vault.
No, yeah, I kept it in keyword and I share that model to another workspace.
They need to have permission to that category key vault. Okay. So while that's why the service connection will be used. Okay. So the credential, usually you can, if you are in a same subscription, you can share that particular credential with a different workspace also.
Yeah, they have to be in the one subscription, same subscription. If they are in different subscription, then it will not work.
You have to register it on the credential need to be go to their key vault. The key vault cannot be shared.
Yeah, so that has to be done separately from this model.
Yes. The credential need to be shared by manually only. So here, if I come to this one, I come to the data. I have a taxi test request. As always, I'm lazy enough. Just I copy this and test it. So this 2 columns is for 2 vendors. I'm just copy this, come to the demo, and where am I pipeline? Where is my deploy model? Prediction. Oh, where am I? Okay. So where is my model endpoint? Come to the endpoint. Oh, sorry, I'm in a different directory. I'm coming to the different workspace, which is a development. I'm going to go to my endpoint, and this is a production endpoint. It's a production model, which I'm deployed on a different workspace and try to consume. and test with the test data. I'm copying the test data and clicking, and it give a prediction. The first vendor giving it $12 and the second $12 and $15. Okay, so this concluded what we want to achieve from our demo. I'll come to the last part, which is a responsible AI. So this is a step. We provisioned the whole infrastructure, dev workspace, and everything we did it via infrastructure as a code. We've not done anything manually. And Azure registry, now you got what is the power of Azure registry. You create a model and expand. Then comes to the responsible AI. I want to go through the quick demo. Even you guys can go test it. Okay, I'm not going to use this data. It is used. We can do it, but this is more UI friendly, and it's already given as a demo by the. What happened? Internet is disconnected. REI dashboard. Okay. Sorry. So Microsoft has a dashboard, which you can try a demo here. Wow. It was working at night. It's not working here. Fantastic. So, but we will go to our code and check it. Okay. But you need to run a compute. I'll run a compute to do that. But the concept is same. It will do the fair and it predict and everything. I'll take a questions. In meanwhile, the responsibility is building a. So model, I come to my model, okay, taxi and responsible AI, and create a responsible AI, create a dashboard. Okay, no, it's already there. Explain fairness. First, we can do the fairness preview. The data will be there. Okay, here it's already the dashboard is here. So here you can see this is a based on the metric, it will give you the error coverage. What is the error coverage? This is the error coverage. I don't know how I can make it big, but it will tell this is your error, and it'll give you the you can export as a PDF also. So predicted path is greater than 12 kilometers, and it give you the temporary cohort. Okay, what is the difference between on what metrics it is used for explain the model, what prediction it is giving between the model, and it give a data analysis for which value it is giving you, the latitude and longitude. Based on that, it is giving a prediction, and which feature is important. See, the distance is very important on the pricing. Okay. So counterfactual. So what if the counterfactual, if you want to ask, is what if the data is different, and analysis, and how are we going to be, how we are addressing the issues. This URL, this one, you need a multiple compute to have a UI, but the concept is same. That's why I want to give the demo. Yesterday it was working, but as usual. REA dashboard. So Microsoft dashboard. Okay, it's sorry guys. Okay, it's in a slide. You can go. It will give you the prediction of the house prediction. So if the square, what parameter used for the house prediction, whether it is size or locality, and what made them to come to this cost, and why it is biased, why the old building is biased. So it will give a better look. You can check it after this. So that's how I concluding the session. Where am I? I want to make sure that I'm covered everything what I want to cover. Yeah, the demo, we end up in doing a lot of screen switch. Sorry for it. Where is my content? Okay, here it is. Present. So responsibly, you can do the demo. The important thing which I have not covered is the model monitoring. That's very important. And the data drift and model drift, I have not covered it, which is also very important as part of the enterprise MLOps. Okay. So today we covered definite 4 important topics: version the code, data, and your model. The second thing is make sure that you use your MLFlow, something to version your whole pipeline so that you can understand what model is run for which data important, which help you to version your model. And the third one important thing is responsible AI. Anytime you're building, always make sure that your data has all the responsible AI covered. Then use the framework to set up the infrastructure. Don't have some kind of framework which is developed by the MLOps V2 accelerator, which give you the quick quicker to do the repeatable things again and again in a scalable manner. And fourth thing is, if you have a multiple environment, how you are sharing your assets with your team to work in a scalable manner. So with this one, I'm concluding my session. I'm ready to take up a question. So I'm ready to take up a question from online, some people who are into the session. So, and then I'll come to the thing. Anybody from the online have some questions? They can speak, right? Okay.
They can speak.
I don't have any questions, but I see there are some asking about GitHub workflow for the machine learning.
System audio, your laptop system audio.
Okay, GitHub workflow. The one I was showing, or they are asking, is there any GitHub workflow for the machine learning operation? Can I understand the question a little bit more in detail? Or please type, okay. I'm happy to, if you are not able to answer, you can type here in this session. I'm happy to answer from here. The one which I shown, okay, that is the GitHub actions which you use for training the machine learning ML pipeline. The ML pipeline which I shown, right? So it will the recorded which video, yeah, that I leave it to AA camp. Okay, I leave it to the AA camp on that. Okay, the one I shown, it's the YAML file, and it has a list of steps. Now it go in a flow of take the data, prepare the data, train the data, build a model, and create that responsible AI flow. Just make sure your model is covered all those responsibly. That's the coverage. It's all in YAML file. Okay, it's all in YAML file, declarative. I not done it. It's already there. I made some changes to have all those the responsible AI to be added to that particular code. Okay. You can add this registry also, whatever the registry I did, right? If you already team, whenever you build a model, share it to the common registry. You can do that also as part of the pipeline. I was trying next to that one. Okay. Any questions from here? I go. Even if it's a small question, feel free. Okay. Yeah, go on.
Is there any way to do like A/B testing on endpoints?
Yeah, definitely you can do it. Okay.
If I want to distribute traffic between 2 or 3 models.
Definitely. There is currently I did a managed endpoint. Okay. There is a way to do in a Kubernetes endpoint. Okay. The enhancement which I want to try next is I want to deploy this in a Kubernetes with a blue-green deployment. The blue will go with the model version 1 and the green will go to the model version 2 and do this traffic analysis that I can do it from the Kubernetes endpoint. That is doable, but you need to share that particular model to the
So I have, let's say, 2 or 3 models available.
You can do it.
Then I can create one endpoint that can.
No, you have to deploy multiple. You can connect to the single Kubernetes. You can have multiple managed endpoint. Yeah, that is doable. Then from your application, you can build a traffic. Or here in a single managed endpoint also, you can do multiple model and split the traffic. So here, if you go to the endpoint, right, there is something called traffic. Okay, if I go to this, okay, deployed here. I deployed here, right? Yeah, I deployed here. If I go to the endpoint, I here deployed only one model and updated the traffic. Okay, here this is the only one deployment. You can do the multiple traffic and update the traffic. Whether to the deployment name proto dev, you can have a model 1, model 2, and split the traffic. It's very powerful. Okay, so any questions? Students, feel free to ask more questions. There is nothing for split question. I have experience after 2-hour session. Tell me a little bit about machine learning. That is also fine. Okay.
Can you show about model monitoring a little bit? What parameters you get?
See, they have something called application insights, which will give you the traffic throughput. Okay. Model monitoring, you have to build a little bit on what is your requirement, particularly on accuracy state, do the test data and see whether the accuracy is good. If the accuracy is not good, and the model drift and the data drift work in a very scalable manner on data by data. So very simple concept. What is model drift? So everything need to have a baseline. Okay. So there's a trade-off between accuracy and amount training I need to do. Okay. And some data we cannot accurate. Definitely may not accurate 99%. The moment you do the 99, then you have a bias or you will have a skew of the prediction. So you will need to have a baseline. I can predict only maximum of 90%. That is fair enough. Then what will happen? I deployed a model with a new version. It changed my model accuracy. Okay, that is a little bit on the model drift. Again, it will go back to the data. What is my basic schema structure of the data? And whether I might add a new bias or introduce a new bias, which created a drift in the data, which lead to the model. Okay, and it will go in a loop. Whenever there is a new data comes, they will retrain the model and do it. There is a new announcement. I had come to check. Whenever you're making an endpoint, right? Making a call, that's a real data. You can do how much ever the data predict in your laptop, but the real data will be different. So what they do, whenever the real data comes, parallelly it will predict and store it into the raw zone. Okay, the new data came. This is accuracy provider. It will keep on accumulating all the things and use this input to retrain your model, come up with the new version of the better model. Okay, it's a feedback loop go like that. Okay, so there they can find any model drift is happening, data drift is happening. Okay. But everything go back to how you are baselining it, how your model is drift from your baseline, and what is the changes happen in your data. That's why the data versioning is very important. Okay, I cannot randomly introduce a new schema or the new structure data and expect my model behave properly. Is it useful?
Yeah.
Okay, thanks. Any more questions?
There another question on the room chat.
I'm checking. Okay, we can deploy a model to the Streamlit in a straightforward manner. What benefit Azure can provide for a small scale application? Yeah, what I did is a small scale application only. I not scratched my head so much. Simply YAML file and told this is a model Azure registry, deploy it. So I'm not well versed about Streamlit. Okay, I find this also straightforward. Okay, it's a simple YAML file. Deploy this model. That's it. For you, it's very complex. Okay. Yeah, I need to test Streamlit and see how easy it is. I don't have background on it. Okay. So for me, it's nothing but a model. You package it, containerize it, and deploy it. That's how it is. Yeah, definitely it will be a easier way also. I don't counter argue. Any questions from online?
Streamlit is from Azure again.
I don't know. I really
Which one
don't.
is Snowflake?
It's just a front end layer, right? Yeah.
I don't know.
The front end DevOps, it just does that.
Then it does not, scale.
Yeah, it doesn't do anything.
It just, for your own experimentation purposes.
Yeah, I'm talking about the enterprise scale. Okay, the real objective today is to we can play anything around in my laptop. My working in my laptop is fun, okay, but enterprise need a scalable one. That's why we are focusing here. You throw out the traffic and keep a compute minimum. It can be 1 and maximum it can go to 200. You can auto scale automatically. You can just sit back and relax, and you can do the blue-green deployment. You can connect your existing infrastructure like a Kubernetes deployment. Okay, so that's all really matter at the enterprise scale. Yeah, running a testing in a local, you don't need all those things. The MLFlow, you can test it in a local. You can, now they created something called MLFlow pipeline, which you can do everything.
Again, one more very basic question. Sorry, my understanding is very limited. So training the model is again one of the services from Azure. So let me tell you where I'm coming from. So earlier we used to take a machine and then we deploy whatever the tools that we need for the ML to get it trained and then give us the model. But now are we again creating the machines on Azure, or like are these services directly available so that we can directly
Here, while you're training the model, what does it do in the pipeline? It will launch the compute on demand. When the training is done, it will go off. Okay. In a training, there are multiple advanced concepts. Currently, while you're training the model, you can tell what compute I need to use. It will automatically train, and the compute will run only during that runtime. It doesn't mean that it will run all the day. I'll train once in a week or once in a month. No, it's not like that. In the YAML file itself, you tell, and the ML pipeline that YAML file itself tell, for training, use this compute. If the model is big, use this particular one. There are multiple concepts like a distributed training. If the model is big and the data is big, you cannot fit into the one computer, you can do the distributed training. So those for our advanced topic, we can include on this, but simple, you can tell this is a compute use. It will launch it at the time of training and it will go off once the training done.
So it's a service, it's not a machine.
It's a service. It's all declarative in the YAML file. So that's the power of this accelerator version, but it's all have a cookie cutter. All you need to do is download this and follow the documentation or use the session version or the source code I posted. The sparse output that nobody's put it. That's why I put the sparse output. Nothing but after running the script, it will give output. So you can go refer it, how it is structured, and you can test it. Any bug, reach out, just message me when I find a time. I will definitely respond on it. Last one question. If not, we can conclude. From online, if nobody has any questions, we are concluding. Okay.
Any plans for future events?
Sorry.
Future events like next week.
Future events. Okay, they will address from the A camp, will address from the reactor. Okay. And off the record, people who liked my presentation, tune on December 14 on the reactor session. I'm going to speak on the same topic. I try to test on a Kubernetes before I'm coming. I cannot guarantee it. But the same topic will be different. The same topic will be discussed there.
It's the same topic.
Yes. Yeah, future session, definitely we have a plan. Okay. This is the second session happening. It's happened on the MLOps. Before the session, we did it on the basic, very fundamental, like what is the difference between MLOps, DevOps, how the MLOps inherited. We were talking about that particular session. Okay. I got bored with this doing the same session, so I come with this one. So definitely a lot of interesting thing. I want to think about the model monitoring and think about the model drift and data drift maybe on a next session. Scalable manner. And I want to improve my demos because last time I did, it's taken a lot of time to show the demo. That's why I built everything. I want to show it on the live. Good. Thank you.